निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Hello students. Today in this session we would be continuing with the solution of exercise 12.3 from chapter 12 areas related to circle from NCERT textbook class 10 mathematics. In our previous session we had completed the first two questions from the exercise. Let us continue today with the third question. Find the area of the shaded region in the given figure. The figure is given to us and the shaded region is also given to us. If ABCD is a square of side 14 centimeter, if ABCD is a square, so ABCD is a square means AB is equals to BC is equals to CD is equals to AD and each side is given by 14 centimeter. APD and BPC are semicircles. APD and BPC are the semicircles that are given to us. If APD or BPC is a semicircle, then we can say AD or BC is the diameter of the semicircle. That means the radius of the semicircle can be the half of AD, that is 7 centimeters. So the radius for the semicircles should be considered as 7 centimeter, AD being the diameter of the semicircle. In order to find the area of the shaded region, if you observe it, this is area of the square minus area of the unshaded region. That is, we have to subtract two semicircles which are unshaded from the whole square to get the area of the shaded region. So let us continue. Area of shaded region is equals to area of square ABCD minus area of the unshaded region, that is two semicircles. The unshaded regions are given by the semicircles, the two semicircles. These are the unshaded regions. So if you subtract this unshaded region, these two semicircles from the whole square, we get the area of the shaded region. So let us continue. Area of the square is given by the formula, that is sine square, and we know minus area of two semicircles. Area of one semicircle is half the area of the circle, that is half pi r square. And since there are two semicircles, so we can multiply by 2. Continuing with the solution, the side square, the side of the square is 14, so we can write 14 square minus, this is the area of the square, minus 2 into half pi r square. The value of the pi, we must take it as 22 by 7 and r square, that means r is the radius of the semicircle that we have taken as 7 centimeters. This is into 7 into 7. So this is 14 square, 196, and solving this part, this 2 and this 2 cancels, 7 and 7 cancels, 22 into 7 is 154, and if you subtract 154 from 196, you get 42 centimeter square. So this is the area of the shaded region that is required from our figure that has been given in question number 3. Moving on to the next question, question number 4. Find the area of the shaded region in the given figure. The figure is given to us where a circular arc of 6 cm, this is the circular arc, has been drawn from the vertex O of the equilateral triangle. So OAB is the equilateral triangle of side 12 cm. The side of the equilateral triangle is 12 cm. A circular arc has been drawn with radius 6 cm. The whole figure is a shaded part, so we need to find the area of the whole figure that has been given to us because the whole figure is shaded. In order to find the area of the shaded region, if you observe very clearly, there are two parts given out there. One is the equilateral triangle, and the second is the major sector. If you see, it's a major sector. If you add the area of the equilateral triangle with the area of the major sector, we get the area of the total shaded region. In order to find the area of the triangle, the side is given to us as it's an equilateral triangle, and we know the formula for finding the area of equilateral triangle by the formula root 3 by 4 side square. We have that side. For finding the area of the sector, we are given with the formula theta by 360 into pi r square. That means two things are unknown there. One is theta, that is the central angle, and second is the radius. The radius is given to us and theta is still unknown. So we have to find that central angle first. How to find the central angle first? Now this was an equilateral triangle. That means each angle is 60 degrees. So this angle is also 60 degrees. The total angle is 360 degrees. So let us consider the theta, that is the central angle for the major sector, as denoted by the symbol theta, and that can be calculated by subtracting this 60 degree from the total 360 degree. You can very well see that if this is a whole angle 360 degree and this much part is left out, that means this major central angle would be calculated by subtracting this 60 degree from the whole angle 360 degree. And we get that central angle from the major sector. So first of all, let us find out that central angle for the major sector. So central angle for the major sector, say denoted by theta, and that theta is equals to 360 degree minus 60 degree is equals to 300 degree. Now we have got the central angle for the major sector also. Now we will find the area of the triangle, the area of the sector. We will add both and we will get the total area of the shaded region. So let us move. Total area of the shaded region, and that is equals to area of equilateral triangle OAB plus area of, this is equilateral, area of major sector ERP, area of major sector PRP. Let us divide so that we do not get confused. Now area of equilateral triangle is given by the formula root 3 by 4 side square, and area of the major sector is given by theta by 360 into pi r square, where theta is equals to 300 degree that we have calculated. We could have calculated that part here also by writing 360 minus theta, but we have found it previously only. So it should not confuse you. Now substituting the value, this is root 3 by 4 side square, the here side is 12, so this is 12 square, plus here theta we have calculated for the major sector as 300, this is 360, and the value of pi is 22 by 7, and radius is given to us as 6, so this is 6. Simplifying it, we can get root 3, and this is 36, so this will be 36 root 3 plus 3 tens are and 3 12s are. Nothing else can be. Yes, this is 2 6 and 2 11s. And this 6 is also. So we have this one 10 into 11 into 6, 6 into 11, 66, 660 by 7. This is 660 by 7 centimeter square. So this is the final answer. You can say this is for the area of the shaded region that was asked in our question number 4. We could have calculated more if we could substitute the value of root 3 so that we can obtain the answer in decimals. But it is not necessary out here. We can keep the solution as it is. So the next question, question number 6. Question number 5 has been left out for your practice purpose. So you can go through your NCERT textbook and practice the question number 5. Then we move in with question number 6. In a circular cover, this is a circular cover of radius 22 centimeter, a design is formed leaving an equilateral triangle ABC in the middle as shown in the given figure. We are given in the figure that is a circular table cover. An equilateral triangle has been left out in the middle and the remaining parts of the designs. We need to find the area of the design. We have to find the area of the design. If you observe it very clearly, the area of the design is the shaded part of the given figure. And the area of the shaded part can be found out by finding the area of the circle minus area of the unshaded part, that is minus area of the triangle. So we need area of the triangle and moreover we need the area of the circle. In order to find the area of the circle, the formula is pi r square. We are given with the radius. We can very well find out the area of the circle. And since ABC is an equilateral triangle, the formula for finding the area of an equilateral triangle is root 3 by 4 side square. The side is not given to us. So first of all, we need to find either of the sides of the equilateral triangle. How to find out? We are given with the radius OB as 32 centimeter. Let us draw a perpendicular from O or BC. And we know that the perpendicular drawn from the center to the chord bisects the chord. So first of all, let us draw and name it as B. Now BD will be equals to CD. As soon we draw the perpendicular, draw OD perpendicular to BC. This will divide BC into BD is equals to CD. This is a theorem that we have gone through in class 9. Now this one is also 9. Applying the trigonometry, we can get BD. For applying trigonometry, again we need two things, an angle and a side. We are given with the side of the triangle OBD. There is no angle. The angle is given, that is hidden. Let us check out that angle. Since ABC is an equilateral triangle, each angle is 60 degree. Then, if each angle is 60 degree, OB is the bisector, so this will be 30 degree and this will also be 30 degree. If you are moving at the vertex B, this is one method of finding the angle. The second method is, you can join this also. Then again you can apply the theorem that you have studied in class 9. That angle at the center is double the angle on the remaining part of the circle. This would have been 60, this total would have been 120, and OD being perpendicular, each will be 60 degree. We can move out from that way also. We will be moving this way. Taking this angle to be 30 degree. Now in triangle OBD, we need BD. If this is the angle, then this would be my adjacent and this is my hypotenuse and OD is the height. We are interested to find the adjacent part, that is BD, and that is given by cos 30. Cos 30 degree is always adjacent by hypotenuse. So adjacent is BD and hypotenuse is OD. And what is the value of cos 30? This we have gone through in chapter 8. The value of cos 30 is root under 3 by 2. And this is equals to BD. We are interested to find the BD. BD as it is and OB is given to you as 32. So you can solve it and get BD as 32 root 3 by 2 centimeters. We haven't reached to find the side of an equilateral triangle. The side of the equilateral triangle is BC, and we know BD is equals to CD. That means if we want to find out the value for the side of the equilateral triangle, that is BC, we will have to double the BD. So BC is 2 times of BD. So you can write 2 into 32 root 3 by 2 and this cancels, and you get the side BC as 32 root 3 centimeters. Now you have got the side for the equilateral triangle, and now we can directly move on to find the area of the design, that is the shaded region. Let us write area of design, and that is equals to area of circle minus area of the equilateral triangle A, B and C. Area of circle is given by the formula pi r square minus area of the equilateral triangle is given by the formula root 3 by 4 sine square, and the sine is here BC square, so we can write that BC square. Substituting the values, the value of pi is 22 by 7. The radius is given to us as 32 for the circle, so this is 32 into 32 minus root 3 by 4, and BC we have calculated as 32 root 3, so this is into 32 root 3 into 32 root 3. The whole answer that we will be getting in centimeter square. Let us simplify it the way we want. You can solve this separately and you can get the answer, or you can find some simple method for solving also. Let us move on with some simple method. 32 into 32 and 32, we can take out common 32 into 32. Here we have 22 by 7 minus. The remaining is root 3 into root 3 into root 3. This is root 3 into root 3 is 3. 3 root 3 by 4 centimeter square. So this is 1024. The square of the root is 1024. This is 88 minus 21 root 3 by 28. If you take the LCM for the bracket, and we can simplify here also. Let us write this one again as 32 into 30 so that the cancellation would be easy. 7, 4, this is 28, and 4, 8, so this is 8 to just 16, 1, 24, 256 into 88 minus 21 into 3, 4 divided by 7 centimeters. So this is the final answer for the area of the design that was left out by cutting an equilateral triangle or by leaving an equilateral triangle in the middle of the given circle. Moving on to the next question. Question number 8. Again, the question 7 is left for you for practice purpose. It's an easy one. You can go through your NCERT textbook. We'll be moving with question number 8. The figure depicts a racing train whose left and right ends are semicircles. This is the figure given to us. It's a racing track. The shaded part is shown by the racing track, and the two ends are the circular ends on the left hand side as well as on the right hand side. The distance between the two inner parallel lines segment is 60 meters. That means these are the two inner parallel lines, and the distance between them is 60 meters. So let us draw this one as this distance is 60 meters. And they are each 106 meter long. That means the inner straight lines are 106 meter long. So let us take this side also. So this distance is 106 meters. And if the track is 10 meter wide, the track is 10 meter wide. You can extend this line, and this part, this much part, this is 10 meter. You can say this side also. This is 10 meter. If you want to move this side also, you can say this is 10 meter, and this side also, this is 10 meter. Find the distance around the track along its inner edge. We need to find the distance of the inner edge. This total distance we have to find. In order to find the distance of the inner edge, we know that this is 106 meter and this is also 106 meter. This is a semicircle and this is also a semicircle, two equal semicircles. We need to find the radius of the semicircle. Now the total distance between the two parallel lines was 60 meters. So you can say that 60 meter is the diameter of the semicircle. So if you want to take the radius would be 30 meters, the half of the diameter. And the first thing that we have to find out is the distance around the track. So distance around, let's find out first. The distance around the track. Around the track of its inner edge. That is the length of this arc, the length of this arc, and this straight line plus this straight line. So we have 106 two times. So you can say 106 into 2, and the 2 curve part is given by plus half 2 pi r. 2 pi r is the total circumference of the circle. It is a semicircle, so it is multiplied by half, and there are 2 semicircles, so the whole is multiplied by the 2 once again. So this 2 and this 2 cancels. This is 232 plus 2 into 22 by 7 into the radius for the inner semicircle that we require is 40. That we have checked out, calculated also. So this calculated as 232 plus, we multiply and simplify it. This is 22 into 2, 44, and 44 into 3. So multiply from there. 21320 by 7. If you find the LCM and then solve it, this is 1441 into 2 and 1424 plus 1320 whole divided by 7. If you add it, this is 2744 by 7 centimeters. This is the total length of the inner edge of the circular racing track. So final inner edge is 2744 by 7 centimeters. The big 2 part of the question number 8, that we need to find the area of the track. That means we need to find the area of this track. So let us divide it into 4 parts. This is part 1, this is part 2, say part 3, and part 4. And the sum of the areas of part 1, part 2, part 3 and part 4 will give the total area enclosed in the circular part. So the part 1, if you observe it, it is in the shape of a rectangle, and part 2 is also in the shape of a rectangle whose length is 106 meter and breadth is 10 meters. So we can very well and easily find out the area of part 1. Area of part 1. Length into breadth, because it's a rectangle and the area of the rectangle is length into breadth. This is 106 into 10 is 1060 centimeters. Sorry, this is everything is in meters. This is meters square. Area of part 1 and area of part 2 will be same. So we can directly write area of part 2 is also 1060 meters. Then we need to find the area of part 3. So this is my part 3. Outer semicircle, the area of the outer semicircle minus the area of the inner semicircle will give me the area of the shaded region in part 3. So let us find out the area of part 3. So area of part 3 is area of outer semicircle, that is with radius is equals to 40 meters if you see, minus area of inner semicircle, that is with radius, that is 30 meters. So area of outer semicircle, the area of the circle is pi r square, so semicircle is half pi r square, so this is half pi and radius is 40, so this is 40 square. Minus half pi, the inner one is radius 30, so this is 30 square. If you take out half pi out, this is half 5. This will be 40 square minus 30 square, and applying the identity a square minus b square, a plus b into a minus b, it will be simplified. So this is half 5, and this is 40 plus 30, and this is 40 minus 30. Solving further and substituting the value of pi, this is 22 by 7 into 40 plus 30 is 70 into 40 minus 30 is 10. This ends up, and this is 11. So you get 1100 meters square to be the area of part 3. Now the area of part 3 and area of part 4 are same. So we can directly write area of part 4. This is also 1100 meter square. Now we have got the area for all the parts that were required to find the area of the racing track, that is the area of the shaded region from the figure. So let us find the area of the track by adding all the 4 parts of the track. So area of track, and that is equal to area of part 1 plus part 2 plus part 3 plus part 4. And area of part 1 we had got as 1060. Area of part 2 was also 1060. Area of part 3 was 1100. And area of part 1 was also 1100. In total, it will be expressed in terms of meter square. Let us add this one. This is 1060. So this is, somewhere we can do it, 1060, 1060, 1100, this is 213 and 4320 meter square. So the area of the shaded region from the figure, or you can say the area of the track as per the question. The total area that we have got is 4320 meter square by adding each individual part of the track, that is part 1, part 2, part 3 and part 4. Adding all the 4 parts, we have got the area of the track to be 4320 meter square. We go on to the next question, question number 9. In the given figure, AB and CD are 2 diameters of a circle. AB and CD are 2 diameters of the given circle with center O. So this is the center of the bigger circle, that are perpendicular to each other. The 2 diameters are perpendicular to each other. This angle is 90 degrees. And OD is the diameter of the smaller circle. OD is the diameter of the smaller circle, but that OD is the radius of the bigger circle. If OA equals to 7 centimeter, OA, this one is 7 centimeter. OA is the radius of the bigger circle. If this is 7, then we can say OC is also 7 centimeter. Then we can say OB is also 7 centimeter. And then we can say OD is also 7 centimeters. So if OA is 7, that means the radius of the bigger circle is 7. Then OD can also be considered as 7 centimeters. We need to find the area of the shaded region. We have 3 shaded regions here. One is here, second here, and third. Let us name it. Let this be the shaded region 1. This is my shaded region 2, and this one be the shaded region, the third shaded region. In order to find the area of the shaded region for this half in the semicircle ACB, if you see, we can find the area of the semicircle and subtract the area of the triangle ACB, so that we can get the combined area of 1 and 2, the shaded regions. For third, OD is the diameter, so we can get the radius and we can find the area of the third part by the formula pi r square for area of a circle. Adding 1, 2 and 3 will be getting the area of the shaded region that is required. So let us continue. The first, area of the shaded region 1 plus 2, the combined region, that is equal to area of semicircle ACB minus area of triangle ACB. area of semicircle, that is half pi r square. So this is half pi r square, and area of the triangle ACB is half into base into height. So this is half into base into height. This is let us write once again to make it more clear. That is here r square. That r will be here 7 centimeters minus half into, for the triangle we will consider the base AB and height as OC. So this is AB into OC. And now let us substitute the values that are required or that we can take from the figure. So this is half pi means 22 by 7, and radius of the circle is 7 into 7. So this is the area of the semicircle ACB minus half into the area of the triangle ABC is half into AB is 14 and OC is 7. The total answer that we will be getting in terms of centimeter square. So let us simplify it. This 2 11s and 7 cancel. So this is 77 minus 2 7s, so this is 49. This is 28 centimeter square. So the area of part 1 and part 2 together is 28 centimeter square. Now let us move on to find the area of the third part, that is a smaller circle with diameter 7 centimeter. That means the radius for the smaller circle is half the diameter. That means the radius of the smaller circle is 7 by 2 centimeters. So let us find the area of the third part. So area of third part is area of the circle with diameter 7 centimeters. So area of the circle is pi r square, and here r will be 7 by 2 centimeters. So let us calculate by substituting the value of pi to be 22 by 7 and radius is 7 by 2 into 7 by 2. Let us simplify it. 7 cancels to 11. This is 77 by 2. So this is 38.5 centimeter square. Now we have got the area of the third part, that is that one was shaded. We have got the area of combined area of part 1 and part 2 as 28 centimeter square. So now we have to find out the total area of the shaded region. So let us find the total area of shaded region. Total area of shaded region, and that is equals to area of part 1 plus part 2 plus part 3. And area of part 1 and part 2 we have got as 28 centimeter square, and the part 3 was 38.5 centimeter square. If you add it, this is 66.5 centimeter square. So the total area of the shaded region in the given figure is 66.5 centimeter